Episode 31 of the World of FPGA Podcast. Memory is essential for a lot of things in your FPGA design, and FPGAs have a lot of different memory. Welcome to the World of FPGA Podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. Most FPGA applications need memory. There are different ways to store data inside an FPGA, and the application could be very different from memory for controllers, to store information in registers or configuration in registers, storing filter coefficients and so on. And today I will give you an overview and some deeper insights. So let's start with different kind of memories from small to big. The first are the flip-flops. And no, not the summer shoes. And yes, this is the simplest way of storing exactly 1 bit. It is also called distributed memory, and you can store some bits or some bytes up to several kilobytes of data. If you imagine you have an array of flip-flops, you can use it as a register structure. And there's also the possibility not only to use it as a register structure, you can also include, for example, an AXI Lite interface or an AXI interface. And then you have memory that is can be controlled from an CPU or from another controller over AXI to change data inside this register structure. Oh, a good reminder for myself. I should talk about AXI and other interfaces in the future. Just a note for me. Yeah, flip-flops, so they are the smallest possible way to store information inside an FPGA. The next size is some kind of SRAM blocks. So you can call them block RAM or embedded memory blocks. They have different names, but often they has the same design. They are blocks of SRAM memory cells. It's a static memory, so there is no refresh needed. The typical size is higher than of a flip-flop, of course. It's about around 16 to 20 kilobit for 1 block. And, well, depending on the size of the FPGA, you have sometimes smaller numbers of this kind of memory blocks. Sometimes you have a higher number of memory blocks. So maybe around between 50 and, 800 memory blocks could be possible. And often there are different width to depth ratios you can configure to use this block RAM very flexible. Another feature which is a very important thing in many applications is the possibility to have a true dual port RAM. So you have a memory or memory area, and you can access from 2 ports at the same time. So you have 2 access points for reading and writing. That's an interesting thing. Well, you can also do this with distributed memory, but the SRAM blocks have all the control features built inside in hardware, so it's very, very fast. And they're often used for parameters, for coefficient memory, or as FIFO, or also as ROM. And interesting, you can initialize the values inside the block RAMs within the bit stream. So if you want to use some kind of processor IP, you can create a ROM for your program, so your program memory, and initialize it over your bit stream. So when you're configuring your FPGA, the program for the softcore processor IP is also loaded. It's a nice feature. Next, memory are URAM or UltraRAM, and it's the feature of some AMD FPGAs, which are comparable to block RAM, so SRAM blocks, but they are bigger memory blocks. So you have a higher density of when you're storing your data there. And it has a much better support for cascading memory. So you can put multiple memory blocks together to get one big memory block, and the UltraRAM has some better features and better support for that. Then we get to one point which I've called flash memory. Often this is not a memory you can use as normal memory, flash memory for controllers or something like that. This means more the possibility you can store your bit stream inside an FPGA, inside flash memory cells. So if you're booting up your FPGA, normally you have to read your bit stream out of the standard is QSPI flash device. But some FPGAs have embedded memory in a kind of flash memory, so they can directly start after the booting with their functionality. So it's a non-volatile memory, and this is normally used for the bit stream, which is configuring the FPGA. I'm at the moment not quite sure, and maybe some of from our listeners here can correct me, but I don't think there's memory to use with user space, but well, could be possible. The next is high bandwidth memory. This is a technology developed by AMD, and it is used by different companies since it is getting a standard. So you have HBM as high bandwidth memory, and it is a dedicated special memory chip. So it's more a hybrid, not complete. It is not complete internal, but it is also not an external component if you have this FPGA in your hand. So it's placed on the same substrate, so the BGA package, or on a special silicon interposer, this interposer is sitting between the package and the die. Well, in some cases, there's also the variation that you have memory bonded directly to the FPGA die, so it doesn't go over a silicon interposer. It's directly bonded from the memory chip to the FPGA die. It depends on the manufacturer and the size and the speed and so on. So it's used for designs where you have a very high memory requirement. High bandwidth memory has often several megabytes or gigabytes of memory you can use with your FPGA application. Well, and sometimes internal memory is not enough. And then you need some external memory. And that's only a small outlook here. You have, two possibilities. You can create a memory controller inside your FPGA, or you have sometimes it is hard-coded in the silicon of the FPGA. And when you need more memory, you can connect external dynamic RAM components or dynamic RAM banks or chips and so on to the memory controller and use it internally for whatever you want to use it. In AMD designs, you mostly have an AXI interface, a memory mapped AXI interface to connect maybe your DMA or things like that with the external memory or your controller, processor, and so on. And this memory controller takes care of the refresh rate of the DRAM and of the completely communication to the external components. As I said, sometimes they are in silicon as hard IP, and sometimes you have to create an IP core inside the FPGA logic to control the memory. Other way is you can use an SPI or a parallel bus to connect an flash or an SRAM cell or things like that. So it's also possible to use smaller devices, and the classic thing is you have a flash component connected via SPI, and you use it for the bit stream and also for the configuration or for other data you're using in your application. That's a common case where you can use this kind of chip. Yeah, and that's all for memory at this point. And in the next episode, we will talk about routing. Further information can be found at world-of-fpga.com/WFP031. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye, here next time, your David Kirchner.